Hey everyone, today we are going to solve the Daily LeetCode challenge of 13th March 2024. And the problem statement is find the pivot integer. So let us first understand the problem statement. So according to the problem statement, we have been given an integer n and we have to find out an integer x such that this x is in the range of 1 to n. Okay, and the sum from 1 to x is equal to sum from x to n, such that we have to include this x over here in the sum and we have to also include this x in the sum over here. Okay, so we have to find an x which is in the range of 1 to n such that the sum from 1 to x is equal to the sum from x to n, correct? So if an integer x exists, in that case we are going to return that x, and if x doesn't exist, then we'll be simply returning -1. So let's see for this example, what is the value of x? For this example, the answer, that is the value of x, is 6. Why? We can see that the sum from 1 to 6 is 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. And the sum from 6 to n, what is n? N is 8, is 6 plus 7 plus 8, which is also 21. So since we have the sum from 1 to 6 equal to the sum from 6 to 8, so we can say that we have got a pivot integer x, which is equal to 6. Okay, so let's see how are we going to solve this problem. So for solving this problem, I'll be discussing 3 approaches. So let us first discuss the approach 1. So in the first approach, we will have a for loop that will run from 1 to n. Okay, say this I will loop from 1 to n. Okay, so let me write all the integers from 1 to n. If we have n as 8, so we will have 1 over here, we will have 2, 3, 4, 5, 6, 7, and 8. And our ith pointer is currently at 1. Okay, now what we will do is, for each of the element at our ith pointer, we will find its left sum and its right sum, and we will check whether they are equal or not. If they are equal, then it means that we have got a pivot integer x and we will simply return it. And if they are not equal, we will simply increment our ith pointer and we will move to the next element. Okay, so what we are going to do, we are iterating over all the n integers, correct? And after that, what we are doing, find the left sum, find the left sum. Let me represent left sum as ls, and the right sum, okay? And if they are equal, what we have to do, we have to simply return I, correct? And if they are not equal, what we'll do, we'll simply move the ith pointer to the next element. Okay, so let me write I over here. This I will represent the current value. Okay, and let me write the left sum and the right sum over here. Okay, so our current value at I is 1. And what is the left sum? The left sum would be from 1 to 1. So the sum is 1. And what is the right sum? The right sum is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, which is 36. Okay, so is the left sum equal to the right sum? No, the left sum is not equal to the right sum. So what we will do, we'll simply move the ith pointer to the next element. So we are currently at element 2. Okay, so what is the left sum now? The left sum would be 1 plus 2, which is equal to 3. And what would be the right sum? The right sum would be 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, correct? So it would be 35. Now we'll check, is our left sum equal to the right sum? So left sum is not equal to the right sum. So what we'll do, we'll move the ith pointer to the next element. So now we are pointing at 3. The value of I is 3, and what we'll do, we'll find the left sum. So what would be the left sum? The left sum would be 1 plus 2 plus 3, which is equal to 6. And the right sum would be 3 plus 4 plus 5 plus 6 plus 7 plus 8, which would be equal to 33. Now we will check, is the left sum equal to the right sum? So left sum is not equal to the right sum. So what we will do, we'll simply move the ith pointer to the next element. So now our ith pointer is pointing at 4. Now what we'll do, we'll find the left sum. So what would be the left sum? Left sum would be 1 plus 2 plus 3 plus 4, which would be equal to 10. And what would be the right sum? The right sum would be 4 plus 5 plus 6 plus 7 plus 8. Correct? So the right sum would be 30. So now we'll check, is the left sum equal to the right sum? So left sum is not equal to the right sum. So what we will do, we'll simply move our ith pointer to the next element. So now our ith pointer is at 5. Now again, we'll find out the left sum. So the left sum would be 1 plus 2 plus 3 plus 4 plus 5, which would be 15. And the right sum would be 5 plus 6 plus 7 plus 8. Okay, which would be 26. Now we will check, is our left sum equal to right sum? So left sum is not equal to right sum. So what we'll do, we'll increment the ith pointer. So now our ith pointer is pointing at 6. So what we'll do, we'll find the left sum. So now what would be the left sum? The left sum would be 1 plus 2 plus 3 plus 4 plus 5 plus 6. So the left sum would be 21. And what would be the right sum? The right sum would be 6 plus 7 plus 8. So our right sum would also be 21. Now we will check, is our left sum equal to the right sum? So yes, our left sum is equal to the right sum. So what we have to do, we have to simply return I. So what is I? I is 6. So what does it mean? It means that we have got a pivot integer x and it is equal to 6. So our answer to this problem would be 6. Correct? So now that you have understood this approach, now let's quickly code this. Let us first take a variable I, which would be initially 1. And until our I is less than equal to n, what we have to do is we have to first let's take a variable left sum, which would be initially 0, and another variable right sum, which would be also 0 initially. Okay, now what we have to do, we have to find the left sum, right? So left sum would be from 1 to I, correct? So let's write the for loop. So for int j equals to 1, j less than equal to I, j plus plus, what we have to do, we have to find the left sum. Left sum plus equals to j, correct? Now what we have to do, we have to find the right sum. So the right sum would be from I to n, correct? So let's write a for loop. For int j equals to I, j less than equal to n, j plus plus. What we have to do, we have to find the right sum. So right sum plus equals to j, correct? Now, once we have found out the left sum and the right sum, what we have to do? We have to check whether this left sum is equal to the right sum or not, correct? So we will check here that if left sum is equal to right sum, then what does it mean? It means that we have got the pivot integer x. So what we have to do? We have to simply return I. Now, once we have finished this while loop and still we haven't got any pivot integer x, what does it mean? It means that there does not exist any integer x such that the sum from 1 to x is equal to the sum from x to n. So what we have to return? In that case, we have to return a -1. In the problem statement, it's mentioned that if no such integer exists, then we have to return a -1. Sorry, we also have to increment this ith pointer, right? So let's run this. So it's giving us the correct answer. Let's submit it. So it got accepted. Talking about the time complexity and space complexity, the time complexity is order of n square. Why? Because here you can see that we are running this while loop. How many times? We are going to run this while loop n times, correct? Because this I is starting from 1 and it's going up to n. Additionally, you can see that inside this while loop, we are having two for loops. Okay, so this is going from 1 to I and this is going from I to n. So it's going to cost us a time complexity order of n as well. So order of n into order of n will give us order of n square. Okay, and the space complexity is order of 1 because we are not using any extra space from our end. So now that we are done with the first approach, let's move to the second approach. So in the previous approach, the time complexity was order of n square. So can we have a solution which is better in terms of the time complexity? So the answer to that is yes. So let's discuss the second approach. Okay. So what we will do in the second approach? So as you all have seen that in the previous approach, what we were doing, we were finding out the left sum and the right sum for each of the value of n, right? Because of which it was costing us order of n square time complexity. So now in the second approach, what we will do, instead of finding the left sum and right sum for each of the value of n, what we will do is we will take two variables, left sum and right sum, and we will try to make them equal. Now, what do I mean by trying to making them equal? So let's see. Let me write all the values from 1 to n over here. So we have 1, 2, 3, 4, 5, 6, 7 and 8. So we will take two variables. Let's say this is left sum and this is right sum. Okay, and we will have two pointer. Let's say this is left pointer and this is right pointer. Okay, so initially the value which we will store in the left sum is the value present at our left pointer, so it would be 1, and the initial value of right sum will be the value present at our right pointer, so it's 8. Okay, now until this left pointer is lesser than right pointer, what we will do is we will check that if our left sum is lesser than the right sum, then what we will do, we will try to make this left sum equal to the right sum. Now, how we can make this left sum equal to the right sum? By adding something to this one, right? If we'll add something to this one, then only it will have a possibility of becoming equal to 1, correct? So what we will do, we will increment this left pointer. Okay. Similarly, if the value present at our right pointer would be smaller, then what we will do in that case, what we have to do, say for example that if our left sum is something like 20 and if our right sum is something like 2. So what does it mean? It means that our right sum is lesser than the left sum. So we want to make our right sum equal to this left sum. So how can we make this right sum equal to the left sum? By adding something to this 2, right? So how are we going to add something to this 2? In that particular case, we will be decrementing our right pointer. So our right pointer will move in this way so that we can add the next element to our right sum, correct? What we discussed that if our left sum, let me represent it as LS, if our left sum is lesser than the right sum, in that case, what we have to do, we have to increment the left pointer. So what we will do, we will increment the left pointer, and after incrementing the left pointer, what we will do, we will add the value of our left pointer in the left sum. So we will say that left sum plus equal to the value present at our left pointer. And if we have right sum lesser than equal to the left sum, in that case, what we will do, in that particular case, we will decrement our right pointer, correct? So we will decrement our right pointer, and after that, what we will do, we will add the value present at our right pointer to our right sum. So right sum plus equals to the value present at our right pointer, correct? So now let's do a quick dry run to understand it better, right? So currently, our left pointer is at 1, right pointer is at 8. Now we'll check, is our left pointer lesser than the right pointer? So yeah, left pointer is lesser than the right pointer. Now what we'll check, is left sum lesser than the right sum? Is left sum lesser than the right sum? So what is our left sum? Left sum is 1. So is 1 less than 8? So 1 is less than 8. So what we will do, we will increment the left pointer. So the left pointer will point at 2. And we will add this value to our left sum. So we will add 2. So what we'll get? We'll get 3. Okay. Now what we'll do, again we'll check, is left lesser than right? So yeah, left pointer is lesser than right pointer. Now what we have to do? Now we'll again check, is our left sum lesser than the right sum? So what is our left sum? Our left sum is now 3. And what is our right sum? Right sum is 8. So is our left sum lesser than the right sum? So left sum is lesser than the right sum. So what we'll do, we'll increment the left pointer. So now our left pointer is pointing at 3. And what we have to do next? We have to add the value of left pointer to the left sum. So we will be adding this 3 over here. So what we'll get? We'll get 6. Okay. Now again we'll check, is the left pointer lesser than right pointer? So yeah, left pointer is lesser than right pointer. Now what we have to do? We have to check whether the left sum is less than the right sum. So here it's left sum, here is right sum. So what is our left sum? Our left sum is now 6. And what is our right sum? Right sum is still 8. So is our left sum lesser than right sum? Yes, left sum is lesser than right sum. So what we'll do? We'll increment the left pointer. So our left pointer is pointing at 4. And we will add the value present at the left pointer to the left sum. So what we'll get? We'll get 10. Okay. Now what we'll do, again we'll check, is left lesser than right? So left is lesser than right. Now what we have to do, we'll check for the first case. That is our left sum lesser than the right sum? So what is the left sum? Left sum is 10. What is the right sum? It's 8. So is the left sum lesser than right sum? No. So is the right sum lesser than the left sum? So yeah. So our right sum is lesser than the left sum. It means our left sum is greater. So in that case, what we have to do? Since our right sum is lesser, so what we want to do? We want to make the right sum equal to the left sum. So how can we make the right sum equal to the left sum? By adding something to this right sum, right? So in this particular case, what we will be doing? We will be decrementing the right pointer. So our right pointer will be pointing at 7 and we will add this value in our right sum. So we will be adding 7 to the right sum, correct? So what we will get? We will get 15 over here. Now again we'll check, is left pointer lesser than the right pointer? So left pointer is less than the right pointer. Now what we'll do? We'll check, that what is our left sum? Left sum is 10. What is our right sum? The right sum is 15. So our left sum is less than the right sum. So in that case, what we have to do? We have to increment the left pointer. So our left pointer will be now pointing at 5. And what we will do? We will add this value to our left sum. So we will add this value to our left sum. So our left sum will become 15. Okay. Now what we will do? Now again we'll check. Is the left pointer lesser than the right pointer? So left pointer is lesser than the right pointer. Now what we have to do? Now what is our left sum? Our left sum is 15. And what is our right sum? Our right sum is also 15. Now we'll check. Is the left sum lesser than the right sum? No. So we'll come to the other if case. So what is the other if case? Is our right sum lesser than equal to the left sum? So we can see that our right sum is less than equal to the left sum. Correct. So what we will do in this case, we will decrement the right pointer. So our right pointer will now be pointing at 6 and we will add this value to our right sum. So our right sum will become 21. Fine. Again, we'll check, is the left pointer lesser than the right pointer? So the left pointer is less than the right pointer. Now what we have to do? Now we have to check that what is our left sum? Our left sum is 15. And what is our right sum? Our right sum is 21. So our left sum is lesser than the right sum, right? So what we will do? We will increment this left pointer. So now our left pointer will point at 6. And what we have to do? We have to add this 6 to our left sum. So we'll be adding 6 to our left sum. So what we'll get? We'll get 21. Correct? So now what we have got? We have got that our left sum is equal to the right sum. Additionally, where is our pointer? Our left pointer is equal to the right pointer. Correct? So what does it mean? It means that we have found out a value x such that the sum from 1 to x is equal to the sum from x to n, and we are including this x in the left sum as well as in the right sum. Then only these two pointers have become equal. Correct? So whenever we'll get left sum equal to right sum and both the pointer at the same element, then it means that we have got the pivot integer x. So what we'll do? We will simply return this x. And what is this x? This x is nothing but this 6. So we will simply return this L. Correct. So now that we have understood the second approach, so let's quickly code this. So we will start on by taking two variables, left, which would be initially 1, and the another variable right, which would be initially at n. Okay. And we have to take other two variable, that is for maintaining the track of left sum, which would be initially 1, and right sum, which would be initially n. Okay. Now what we have to do, until this left pointer is lesser than the right pointer, we are going to check if our left sum is less than the right sum or not. So if our left sum is less than the right sum, in that case, what we will do? We will increment the left pointer, and after that, we will add the value at left pointer to the left sum. Okay. So what we will do over here? We will increment the left pointer and we will add the value at left pointer to the left sum. Now, why are we doing this? We are doing this because our left sum is lesser. And what we want to do is we want to make it equal to the right sum, right? We want to make them equal somehow. So how can we make left sum equal to right sum? By adding something to it, right? So it means that we need to add something to the left sum, not to the right sum. Because if we add something to the right sum, so it will become much more greater than the left sum, right? But what we want to do, we want to make them equal. So as to make them equal, we need to add something to the left sum. That's why we are incrementing the left pointer and we are adding that value to the left sum. Else, what would be the else case? Else case would be the right sum is either less than the left sum or it is equal to the left sum. So in that particular case, what we will be doing? We will be decrementing the right pointer and we will be adding the value at the right pointer to the right sum. Okay. Now, if at any point we get that left sum is equal to the right sum, additionally, this left pointer should be equal to the right pointer. Correct. Because then only it means that we have got an integer x such that the left sum is equal to the right sum and both the left and right pointer are pointing at the integer x. In that case, what we'll do, we'll simply return left. You can also return right because both are pointing at the same element. So it doesn't matter whether you return left or you return right. Now, if we are done with this while loop and still we have not got an integer x such that the left sum and the right sum are equal. So in that case, what we'll do, we'll simply return a -1. Additionally, we have to handle one more test case, which is this. If our n is 1, in that particular case, the value of x would be 1, correct? Because initially, if n is 1, then what would be left? Left would be 1 and what would be right? Right would also be 1. So in that case, it will check that whether left is less than right. So this while loop won't hold and it will simply end up returning a -1, which is wrong, correct? So we need to explicitly handle this example that if n is equals to 1, in that case, what are we going to do? We are going to return a 1. Now let's run this. So it's giving us the correct answer. Let's submit it. So it got accepted. Now talking about its time complexity and space complexity. The time complexity is order of n. Why? The reason is that what we are doing over here, we are simply iterating over all the n elements, right? Such that we are finding the left sum from the left to right, and we are finding the right sum from right to left. So we are simply iterating over all the n elements. That's why the time complexity is order of n. And the space complexity is order of 1 because we are not using any extra space from our end. So this is all about the second approach. Now let's quickly discuss the third approach. So as we all saw that in the previous approach, the total time complexity that we were using was of order of n. Now can we have a better solution? So the answer to that is yes. So let's quickly discuss the third approach. Now, before coming to the third approach, what we have to do is we have been given a range 1 to n and we have to find an integer x in between such that the sum from 1 to x is equal to the sum from x to n. Okay. So what does it mean? It means that we have to add 1, 2, 3, so and so up to n. And what does it mean over here? It means that we have to add x, then x plus 1, then we have x plus 2, then x plus 3 and so on until n, correct? So you all can see that what is this? This is an arithmetic progression, right? So what we have to do is we have to find the sum of elements from 1 to n. Now let's discuss that what is the sum of n elements. If we have n elements from 1 to n, then what is the formula? So the formula is n by 2 within bracket a plus l. Now what is this n? This n represents the total number of elements, right? Total number of elements. What is this a? This a represents the first term of the AP. And what is this L? This L represents the last term of the AP. Last term of the AP. But before that, let me also tell you that what is an AP if you guys don't know. So what happens in an arithmetic progression is, say for example, here we have 1, 2, right? So what is the difference between 2 and 1? The difference is 1. What is the difference between 3 and 2? The difference is 1. So whenever we have a series such that the difference between each of the consecutive element is same. So here you can see that the difference between 2 and 1 is 1, difference between 3 and 2 is 1. Then if we would have 4, then the difference between 4 and 3 is also 1. So difference is same, right? It's always 1. So it forms an AP. Similarly, what is the difference between x plus 1 and x? It's nothing but 1, correct? And what is the difference between x plus 2 and x plus 1? It's 1, right? So it means that it forms an AP. So whenever we have been given an AP and we want to find out the sum, right? We have to find out the sum. So this is the formula. So let's use this formula in these two cases. So what would be the sum over here? So the sum would be n by 2. What is n? N is the total number of elements. So how many elements we are having over here? We are having x number of elements, right? So we are having x number of elements divided by 2. And what is this a? This a is the first term of the AP. So what is the first term of our AP? The first term of our AP is 1. And then we have this L. L is the last term of the AP. What is the last term of our AP? The last term is x. So what did we got? We got sum as x into x plus 1 by 2. Now let's find out the sum for this one. So what would be the sum? The sum would be n. So what is n? N is the total number of elements. So what is the total number of elements? The total number of elements would be n minus x plus 1, correct? Here, the total number of elements was x, right? Because we were finding from 1 to x. But here we don't know what this x is. So we want to find out that how many integers are in between them. So what would be the formula? It would be n minus x plus 1. After that, we have divided by 2. Then we have to add the first term of the AP. The first term is x. And then we have to add the last term of the AP. The last term is n. So let's expand this further. So what we will get? We will get x plus n into n minus x plus 1 by 2. So let's open this bracket. So what we will get? We will get xn minus x square plus x plus n into n would be n square. N into x would be minus nx. And then we will have plus n, correct? Divided by 2. So here we can see that this xn and this minus nx will get cancelled out. And rest would remain the same. Let's expand the left part as well. So we will get x into x would be x square plus x by 2. So this should be equal to what? This should be equal to this right part. That is the sum from x to n, right? So what is the sum from x to n? It's minus x square plus x plus n square plus n by 2, correct? So this 2 will get cancelled out. So what we will have? We will have x square plus x equals to minus x square plus x plus n square plus n, correct? So here you can see we have plus x plus x. This plus x will also get cancelled out. Let's send this minus x square over here. So what we will have? X square minus x square. When it will come over here, it will become plus x square. So we'll get 2x square is equal to n square plus n. So let's solve this further. So what we will get? We will get x square is equal to n square plus n by 2. Since we wanted to find this x, so what we will have to do? X would be equal to root over n square plus n by 2. Okay. Now let's observe this. So what is this n square plus n by 2? This n square plus n by 2 is nothing but n into n plus 1 by 2. Correct? So what is n into n plus 1 by 2? N into n plus 1 by 2 gives us the total sum. Remember, when we have a range 1 to n, then if we want to find out the sum of all the integers from 1 to n, then what would be its sum? Its sum would be nothing but n into n plus 1 by 2. Correct? Let's fit this in this formula as well. So how many elements we have? We have n elements. So what it would be? It would be n by 2. What is the first term? The first term is 1. What is the last term? The last term is n. So what is the formula? It's nothing but n into n plus 1 by 2. So what does this give? This gives the sum of all the elements from 1 to n, right? What is this? This is sum of all elements from 1 to n, correct? So what we have deduced from here is that, let's see over here. So if we get a pivot such that its square is equal to the sum of all the elements, then what can we say? We can say that we have got a x and we will return it. Okay, so let's do this one. So let's say in sum is equal to what? It would be n into n plus 1 by 2, correct? After that, what we have got? We have got the sum. That is, we have got this right part. Now, what we want to find? We want to find the left part. So, what is the left part? The value of the left part is equal to the square root of the right part. Correct. So, let's say we have x. So, let's represent x. So, what should be x? X should be the square root of this sum. Correct. It should be the square root of this sum. So, if we get the square of this x. So, if this x square, so let's see over here. If this x square is equal to the sum, then what does it mean? It means that we have got a pivot, correct? So we will say that if this x square is equal to this sum, then in that case, what we'll do? We will return this x. Otherwise, what we'll do? Otherwise, it means that we have not got an integer such that the sum from 1 to x is equal to x to n. So in that case, we'll simply return minus 1. Now, let's run this. Sorry, here it would be into. So it's giving us the correct answer. So it got accepted. Now talking about the time complexity and space complexity. So the time complexity would be order of 1. Why? Because each of the operation that we are doing over here has a constant time complexity. Okay. And the space complexity is also order of 1. Why? Because we are not using any extra space from our end. So now we started on with our time complexity of order of n square in the first approach. Then we boiled it down to order of n. And now finally we have a solution with a time complexity of order of 1. Okay. So that's all about today's daily LeetCode challenge. Thank you.